Hello everyone. Let's get started again. In our previous video, I gave some brief introduction about the continuum mechanics. What is continuum mechanics? Then what are the things we are going to discuss here? Then also I explained the fundamental equation in detail, bit detail, right? We'll talk about in most comprehensive manner when we discuss that particular units again. Right. So now here, I'm going to start the math preliminary for these courses. I'm not going to teach in the entire engineering mathematics. Just I'm going to discuss the brief part. Right? Just, whatever you studied in your previous maths. So only thing I want to formalize your knowledge according to the sign convention what we follow uh, in the continuum mechanics. Right? Mathematics preliminaries. And in this mathematics preliminary, we are going to discuss vector, tensor, scalar, these quantities, these physical quantities we are going to discuss here. The first one, everybody know, scalar. Scalar means we interest only the value of the quantity. We no need to worry about the direction because direction not necessary for this type of quantities. So if I say that in physics level, the mass actually it's a representation of the inertia. So what is the total amount of inertia it has? So that is the mass. So in this case, you no need any reference, frame of reference to measure this mass. Actually, when you measure this mass, we measure actually the weight, not the mass. Then later we convert into the mass. But mass is the scalar. Scalar here we represent by one lowercase letter. Lowercase letter we use to represent the scalar. So this is we define as a scalar. Here we are discussing two different notation. Not two. There are more type of notation in the mechanics. But here I'm going to discuss on the index notation because that is most powerful tools because you can use it in more smart way to represent many number of equation in a single notations. So that is index notation. In scalar, the index notations, we don't use any index here. Just A. This is the index notation in even in the matrix form, even in the index notation, just one letter. Okay. So this is now a scale. So next one is called the vector. So what we define as the vector? To define the vector, you need one frame of reference. Frame of reference. Reference frame you need. So what is frame of reference? You need one stationary point. In that stationary point, we need the coordinate systems. For example, in case of 2 dimensions, we have only x and y. So these coordinate systems, you need one point. So this point is the frame of reference. With respect to this point only, we measure the location of other points. Okay, so here we are going to discuss the continuum mechanics. This reference point we will select at one place, then we can measure other points in the matter with respect to this frame of reference. So This type of quantities, for example, let's say the displacement. Displacement means you need one reference point. If you keep one point as a reference, with respect to that point, you can say the point is displaced with respect to that previous point. So therefore, displacement is kind of a vector. Okay. In vector, to represent the vector, again we use lowercase letter. Then we use hyphen below it, right? So this is the vector, the notation of the vector we use. Okay. This is a vector notation as well as the metric notation, the same. When it's come to the index notation, to represent the vector, we use AI. Here, I we called as a free index. Again, this free index is a dummy index. Dummy index means you can represent by any letter. Instead of I, you can use K, you can use L, M, N, whatever the letter. So we don't use O, okay, because it confused with the numbers and everything. So normally we don't use O. Other than O, then we can use any letter for here. Right? It is dummy index. Again, if you consider number of free index here, number of free index, it is 1. So that means if we have number of free index 1, that is the vector. In scalar, we don't have any free index, no free index. If number of free index is 0, that is the scalar. Number of free index is 1, that is the vector. So another one we are calling as tensor. Okay. So before going to the tensor, I will tell you one more things. To represent the vector in a coordinate system, let's consider the 3-dimension, right? This is for 2D, 2-dimension coordinate system. I have drawn here. If I take the 3-dimension system, so this is X, Y, and Z. If we want to represent any vector, so normally we use the column matrix to represent this vector. So for example, this vector has 3 components along X, Y, and Z. So let's say each component is, okay, I'll put like this: X component, Y component, Z component. So in mathematics, you studied these things to represent this one. Okay. Then here, we use AI, right? So if I want to use the same the notation consistently here, so I can represent like this: AX, AY, AZ. Okay. These 3 I can represent in one single notation. That is the benefit of index notation, because no need to write like this every time. If I write AI mean, actually it representing this column vector, one column matrix. So that is the useful of this index notation. Okay, so now let's move on to the tensor. Tensor, we have many tensor. The first one called second order tensor, right? Okay. Okay, I'll put you this way, right? Even if you take the scalar and vector, these are also tensor. It's something like that. You studied in your mathematics set theory, right? In the set, this is the universal set for this these things, right? If I say tensor, tensor including scalar, vector also included inside the tensor. The first one, let's say, I will put this way, number of free index. Then I'll put order of tensor. Okay. So for example, if you have zero free index, no free index mean that is we call zeroth order tensor. I'll put zeroth order. That means you know what is this. Zeroth order tensor. So this is actually, I'll put remarks here. This we define as a scalar. Okay. If you have one free index, so that is called first order tensor. So that is your vector. That's already we discussed. We have only one free index. So let's say I'll put this one also notation also A. So this is AI. Now if I write AI, this is the vector now. Okay, because I included the free index here. Let's say if you have free index 2, this is called second order tensor, right? So in this case, to represent the second order tensor, we use uppercase letter. Then the matrix notation, we use tilde. Index notation, because we have two free index, we will represent like this, AIG. Okay. Here we have two free index here, AIG. If you have two free index, that is called second order tensor. Similarly, if you have three free index, that is called third order tensor. Again, this also we represent by the same uppercase letter, tilde. Okay. So here you need three free index, right? That means I, J, K. Again, I am telling you, this free index as a dummy index. You can represent by any letter, MN or PQR, anything. You can change it by anything, but not same. You cannot write II. If it is II, not a second order tensor. For example, AII, this is not a second order tensor because I is here, not a free index. Here, this I is repeated index, not a free index. Okay, so this is not a second order tensor. This is actually the scalar. We will discuss why it is scalar. We will discuss later. But here I am talking about only the free index. Okay, so like that it will continue, right? It will continue further and further, right? Okay, so this is here I have explained the hand notation. For example, if you read the book, they will follow something like this. Scalar, they will write it in a simple manner. Vector, they will put you the bold lowercase. This is just normal font. This is the bold font. Second order tensor, bold uppercase. This one, even they will introduce more bold. Based on the order of the tensor, they will increase the intensity of the bold. If you read any books, you can find these things, right? Because in every time typing like hyphen or tilde below the letter, it's difficult. That's what they use this these kind of styles when in the books, right? Okay, but index notation, some of the books they use index notation, but personally I prefer the index notation because it makes our life easy. Okay, so we no need to write a lot of equations if you follow this index notation. Okay, now I'm going to start some of the basic definition. In your previous mathematics classes, you studied these coordinate systems. So that means x, y, and z. X, y, z. In this coordinate system, it must follow the right-hand rule. So what is right-hand rule? Let me take three different pen in three color. Okay. Okay, I think this video is bit, I think extended this video. Then I will start the balance part in the next video, right? Okay. So let me stop at this point here now.